Hello everyone. Welcome to my YouTube channel Knowledge Sir. And today in this video I will be sharing about summing amplifier, as well as we will be discussing about how to convert the summing amplifier to an average amplifier by using OpAMP. Already we have posted many videos related with OpAMP, and OpAMP has many different applications, and one of the applications is adder, or it is also called a summing amplifier. Operational amplifier is the most critical and most important component in any of the electronic circuits. Okay, let's go into the topic today, that is how to design an adder or summing amplifier using an operational amplifier, that is OpAMP. So here you can see the circuit. Okay, so this is a circuit, and it is nothing but you will be having a negative feedback. Okay, so the input is also, as you all know, in order to achieve the good voltage stability in almost all the amplification applications, we will be using the negative feedback, and negative feedback is given through R4. Okay, and the input voltage, that is the sinusoidal voltages, are given in the negative terminal. Okay, so this is called as the inverting terminal, and positive is called as the non-inverting terminal. And here you can see that the non-inverting terminal is grounded. Okay, so the output voltage you can see here. Okay, so in the 6. Okay, so this will be 2 and 3. Okay, and then the number 6 you will be seeing the output voltage. Okay, so so how it works? Okay, so how it works is nothing but, see, for example, in this circuit, what this op-amp does is it is going to add all the 3 voltages at the input of the inverting terminal. So the input of the inverting terminal has 3 different voltage sources, that is V1, V2 and V3. And here we will be discussing how the output voltage will be equal to this V1 plus V2 plus V3. So this is what we are going to see in this video. Actually, since we are giving the input in the inverting terminal, the output will be inverted. So instead of getting V1 plus V2 plus V3, what we will be getting is minus of summation of V1 plus V2 plus V3 will be the output. Okay, so this is what we are going to get. Okay, since we are giving the all the input sinusoidal voltage to the inverting input of the op-amp. Okay, so how it happens? So you can see that. So for example, if we are having only V1, okay, if we are having only V1 as the input, then the output voltage, so for example, let us consider that V2 and V3 are 0, and we are having only V1 as input. So this will be nothing but an inverting amplifier, is it right? So this will be nothing but an inverting amplifier. So only V1 will be given to the inverted input, and there is a feedback. So the output V0 will be equal to, as per the inverting amplifier, the output V0 will be equal to, that is feedback resistance, that is minus R4 by R1 into V1. Okay, so V1 is the input signal. So it is very easy to find, is it right? So in order to find the output voltage, it is nothing but feedback resistance divided by input resistance into input voltage. So this is the formula. So V0 will be equal to R4 by R1 into V1. So this is what is written over here. Okay, please understand. Okay, so next, for example, if I am having only V2, okay, the V1 and V3 are made 0 or it is switched off. You can understand that let us have only V2. Okay, so then what happens? So the output voltage will be equal to R4 by R2 into V2. So that's what is given over here. So R4 by R2 into V2. So why this minus is there is because I am giving the input sinusoidal voltage to the inverting input. So the output voltage also will be phase shifted by 180 degrees. So it will be having the minus in the output. Okay. And let us consider only V3 is there. So let us consider only V3 is there, and V1 and V2 are switched off. So now the formula will be minus R4 by R3 into V3. Is it right? So this is what. And so this is what the theory is behind this. Actually, V0 will be equal to minus R4 by R1 into V1 is V1 is only there, and V0 equal to minus R4 by R2 into V2 if only V2 is there, and V0 will be equal to minus R4 by R3 into V3 if only V3 is there. Okay. So suppose let us consider that if all the R1, R2 and R3 are made equal, then you can see that all the inputs and all the inputs are also there. Then you will be getting the output as V0 will be equal to, so it will be added, is it right? So minus R4 by R1 into V1, minus R4 by R1 into V2, and minus R4 by R1 into V3. And my question is, suppose if R1 equal to R2 equal to R3 equal to R4 equal to R, so if all the resistance are equal, even if R4 equal to R1, then what is going to happen is, then this R4 by R1 will be equal to 1. Here also this R4 by R1 will be equal to 1. Here also this R4 by R1 will be equal to 1. So the output voltage will be equal to minus of summation of V1 plus V2 plus V3. Is it okay? So you will be having only V1, V2, V3. So V1 multiplied by 1, V2 multiplied by 1 and V3 multiplied by 1, because R4 by R1 is equal to 1 as both the resistance are of equal values. So here you can see that the output voltage will be equal to minus of V1 plus V2 plus V3. And what this negative sign indicates is, so as you all know that we are giving the input voltage to the inverting terminal. So in this regard, you will be getting the output phase shifted. So you will be getting the negative signal. So the negative sign indicates the PS, that is PS is nothing but the phase shift. Okay. So hope you are all clear how this summing amplifier. So from this itself, you will be having a clarity of how to get the averaging amplifier. So averaging amplifier in the sense, suppose if I am having 1 by 3, so instead of if R4 by R1 equal to 1 by 3, if I am able to set this R4 by R3 equal to 1 by 3, then we will be getting V1 plus V2 plus V3 divided by 3 will be there. Okay, if R4 by R1 will be equal to 1 by 3, then you will be getting V1 plus V2 plus V3 divided by 3. So which will be giving the average of the 3 inputs. So this is what I have written in the next slide. So you can see that R4 by R equal to 1 by N. That is 1 by 3. How many number of branches are there? If there are n number of branches, you have to put 1 by 3. If there are 4 number of branches, you have to put 1 by 4. So since there are only 3 branches, I am putting 1 by 3. So then output voltage will be equal to minus of V1 plus V2 plus V3 whole divided by 3. So from this we can understand that we will be getting the average of all the 3 inputs. So the same summing amplifier can be made to act as an average amplifier by varying the value of resistance, that is R4 by R. So this is the theory behind the theory and working of the summing amplifier and the average amplifier. Okay, hope you're all clear with what we have discussed today. Okay, so thank you very much for watching this video. Hope you are all clear with the concepts which I have discussed in this video. And so if you really like this channel, please give a thumbs up. As well, if you have any doubts, you can just give a comment, and please share to anyone who is really in need of this technical explanations. And really, if you like this video, please subscribe to my channel and you can support this channel. So thank you very much. Thank you.